Hello everyone, today we will be taking apart and talking about LED light bulbs. So LED light bulbs are just mains-powered lamps that have typically an Edison screw base and just produce light through LEDs, and you probably want to see what's inside of one of these things, so let's not waste any more time, and let's whip out the spudger, or well, it's a knife with a razor tip chopped off. Let's see if I can get into this little seam right here and give it a little twist, maybe. Or maybe I can just brute force my way in through it. Let's... my goodness. It's annoying, but I think I will be able to get through this because with LED light bulbs, there is a plastic cover that is snapped in, and you remove that to get to the base. And one moment, please, as I take this thing apart. Okay, that was a tough process, but now, finally, I can crack it open like an egg. There you go. So, let's look at the rating over here. This, where is it? It claims somewhere to be a 5 watts rated LED, as you can see, 5 watts. But there are only 5 LED chips, each of which handle 1 watt of power, actually probably a little less because there's going to be some inefficiencies in the power supply. But I don't think that these tiny surface mount LEDs, well actually they're not that tiny, but still, these surface mount LEDs can handle half a watt, or even can handle a full watt, or even half a watt. So that is an indication of planned obsolescence. They are overdriving the LEDs for extra brightness, and also which causes them to fail quicker so that the light bulb dies earlier and then you can buy more. But there are some screws here, so let's see what's under here. It's very rare to see a light bulb or an LED light bulb with screws, but well, here it is, and it's not like this is some weird light bulb. It's a great value brand, so it's pretty common in the US, I suppose. Maybe not so much in the rest of the world because Walmart doesn't exist outside of the US for the most part. But anyway, it looks like this thing is held on with some more adhesive and stuff. Let's see if I can pop this board out. Oh, that's interesting. It looks like that there is a small switching power supply inside of some kind. Okay. So, now it's almost open, it's just that it's being held together by the mains connections, but you can tell that there's a switching power supply in there. Let's just give it a nice tug. Now the mains connections have broke, and let's investigate. So, it looks like we have, well, apart from the LED board, let's see if I can clip that off with some cutters. Not the green ones, because those are dulled out, the red ones are better. Or at least the red ones are better for now. And let's just get that LED board out of the way, and we have this little switching power supply. Let's see. Well, first of all, I don't see any sort of interference suppression, so all the interference that's created by the power supply is going to go directly back into the mains. At least it has a fusible resistor under this heat shrink. Hopefully you can see a little outline right there. And it has a bridge rectifier after that, so it's a some sort of thing. And also, this little thing that looks like a transformer, it says T2, indicating that's a transformer, because normally if you have T, it's a transformer. But if you look under the board, there are only 2 connections to it, so this is just an inductor. So this isn't a flyback switching power supply, it is a buck converter that is designed to drop a high mains voltage, which would be around 170 volts in the case of 120 volt mains, to a lower voltage, I'm not, probably something like 50 volts for these LEDs. I can't really tell if these are multi-chip LEDs, because it is possible to cram a bunch of LED chips into a single package. That is just to increase the voltage that it would need to run at, and of course the higher the voltage that the LEDs run on, the less complicated the power supply needs to be. And there is a little chip over here. I don't know if you can read the marking. Yeah, oh, you can see it, BP, not British Petroleum, BP 9912C 15H77K F53. Maybe you were able to see that, maybe you weren't, but it doesn't matter. I think it says U. Normally a transistor would be marked as Q instead of U. And U typically means integrated circuit. So this is probably a special switching chip that's in a TO92 package, I think that's what it's called. Typical transistor package for low power transistors. That's that. The primary smoothing capacitor is relatively small, 200 volts, 1.5 microfarad. That isn't good because the LEDs can start, because of all the heat generated, then it might end up losing its capacitance over time, which isn't great. And also, I have to mention that this power supply was just floating inside of here with no thermal connections between the board and case, so it's going to be like an oven in here. The LEDs are going to be roasting, the power supply is going to be dissipating its own heat, and so it's going to be baking in there, and with a long enough run, all of these capacitors will end up drying out somewhat. So that would end up just making the power supply less effective and potentially causing the LEDs to strobe, which would be terrible for people with epilepsy. And it's just that LED light bulbs, they are an amazing technology, but they, because it is possible for them to last as long as you want to, if LEDs did actually last forever, then once everybody had LED light bulbs, then they wouldn't need any more. So the people who design these things cut corners, and you end up with a product that is designed to fail over a period of time. And in fact, let's find out if these LEDs are multi-chip LEDs, because my multimeter has a diode test function, and it should be able to measure the voltage drops of white LEDs. One moment, please. Well, it actually can't measure the voltage drops of white LEDs, so that's a bummer. So I will never actually end up knowing if all of these little LED chips are multi-chip LEDs or just single-chip LEDs. In which case, you would have 6 in series, or I guess 5 in series, which would end up being 15 volts, and it would probably be a challenge to design a buck converter of all things, that steps down 170 volt DC voltage to just 15 volts. So these might actually end up being multi-chip LEDs. But anyway, that's just an example of LED light bulbs and the ways that they are designed to fail over time.